Good morning, students. Am I audible? So, here we are going to start our third unit, that is your specific energy, and this is your very important unit. Okay, when you go for competitive exam, you can find maximum questions in water resource related to your specific energy. Okay, so I think we have already discussed about specific energy. Okay, and total energy. I hope you remember we have two energy, one is total energy and one is your specific energy. Okay, if you remember, in total energy we have jet term, we have pressure head, y, and kinematic velocity head. Okay, or you can say directly velocity head. That means if you consider your total energy, you'll be having two terms. One is your z plus y plus v square by 2g. Okay, the very first class we have already discussed about this total energy. Okay, so when we find the energy with respect to your reference line, or you can say datum, then that energy is your total energy. Okay, when you measure or calculate the energy with respect to the bed of the channel, that energy is known as specific energy. Okay, so when we talk about specific energy, we will be having only two, because with respect to bed we are going to measure. Okay, so above the bed we have only two terms, one is your pressure head and one is your velocity head, that is y plus v square by 2g. So this is the difference between your specific energy and total energy. Okay, okay. So you can see this diagram, we have two section, 1 and 2. Okay, so if you find out the total energy at 1, you'll be getting z1 plus y1 plus v1 square by 2g, and for total energy at section 2 will be your z2 plus y2 plus v2 square by twice g. So these two energy is cannot be same, because we'll be having frictional loss when your water flows from your higher stream to lower portion. Okay, we are having friction at the bottom of the channel. Okay, so because of this friction we have a term called head loss due to friction. Okay, so the total energy at section 1 is equal to total energy of section 2 only when we neglect that frictional loss. Okay, otherwise if you subtract from this to this, energy is equal to, if you take total energy at 1 minus total energy at section 2, you will get the difference is your head loss due to friction. Exact. Okay, head loss due to friction. Okay, so in Bernoulli's equation we consider this head loss due to friction is negligible. Okay, that is your assumption. So that is why we write this is equal to this, that is z1 plus y1 plus v1 square by 2g is equal to z2 plus y2 plus v2 square by 2g. Okay, so these things I think we have already discussed. Okay, so in Bernoulli's equation we consider there is no friction loss, and that is why we equate both the total energy for both section. Okay, so this is a definition of specific energy, or you can simply write of your own also. Okay, in own words, that specific energy is the amount of energy expressed in pressure head and your kinetic velocity head, and it measures with respect to bottom of the channel. Okay, that is your specific energy. Okay, so now specific energy is equal to y plus v square by 2g. Okay, so this is the equation. So here we have y plus, in place of v we can write q by a. Okay, this is equal to area into velocity. So in place of velocity you can write q by a. So here we can write q square by twice g a square. Okay. This is nothing but we have only substitute in place of v, we have substitute q by a. Now see what we are going to do. We are going to draw a graph between your energy and your depth of flow y. Okay. Your energy will be in x-axis and your depth of flow will be in your y-axis. Okay. See, we all know this depth of flow, the unit is in meter. Okay, and this v square by 2g, this unit is also in meter. So that is why the unit for your specific energy, for this specific energy, is nothing but your meter. Okay, okay. So the graph we are going to draw, both the unit is same. The depth of flow will be in meter, and that this specific energy is also will be in meter. Okay. Then we consider by drawing a straight line at 45 degree. Draw a straight line at 45 degree, and this is nothing but your E is equal to y. This is an imaginary line, and why we need to draw this line, I'm going to tell you. Okay, okay. So we are going to draw a graph. That graph is called specific energy curve. Okay, between your specific energy and depth of flow. Okay, so that specific energy will be in your x-axis and your depth of flow will be in y-axis. Okay, now we draw a straight line at an angle of 45 degree, and we consider this line is E is equal to y. Okay, so now we all know in open channel flow, first we measure discharge. For that particular discharge we design the canal. Okay, for that particular discharge what will be the specific energy, that also it depends on the particular discharge. So what we do, this discharge we will consider at constant. Okay, so that for particular discharge what will be your specific energy, or what will be your specific energy curve. Okay, so for that particular discharge, if you want to draw a specific energy curve, it will come under this portion. Okay, for a particular discharge, if you want to draw a specific energy, it will come under this portion, that is the below portion of that particular line. E is equal to y. So that is the purpose we divide the portion by using this line, and your specific energy curve will be in this portion. Okay, for a particular discharge. Then for the same channel, if you change the discharge, then you will be getting another specific energy curve but in the same area. Okay, so this is q1 and this is q2. Again you change the discharge. For that particular discharge, other parameters are same, that for that same channel, if you change the discharge, you will getting another specific energy curve. Okay, so if you have any doubts you can ask me here. Okay, because this is very important. If you understood, then it's very good. Or if you have any doubts you can ask me. Okay, Okay, fine. Okay. So if you see, if you consider a rectangular channel, width of the channel is b and y is the depth of flow. Okay. So I think you are familiar with this equations, y plus q square by twice ga square. Okay. So here you see the q is constant. In place of area, we can, for a rectangular channel, we can write b multiplied by y. So that means that area is also function of y. Okay. Area is also a function of y. Okay. So if you change the discharge, your depth of flow will change, but the width of the channel, it remains same. Okay. That this width of the channel is a physical parameter. It's not going to change, or it's not a function of q. Okay. If you change the discharge, your depth will change. Once the depth will change, your area is also change in that particular channel. So that is why your area is a function of y. Okay. So ultimately, if you see in this question or in this equation, if your q is constant, then we can say our energy also is a function of y. Okay. And that is the reason why we draw a graph between your depth of flow and specific energy. Okay. So for this graph, you can just take one example and see how this graph coming. Okay. You can take an example. You can write it down. Discharge is equal to 4 meter cube per second. Okay. Then width of the channel is 2 meter, and then y is the depth of flow. Okay. It's a rectangular channel. It's a rectangular channel where width of the channel is 2 meter and depth of flow is not known. Okay. Discharge is given 4 meter cube per second. Okay. Now what we are going to do, we use the specific energy equation, that is nothing but y plus v square by 2g. Okay. So this is y. In place of v, we will write q by a. So q square by twice a square. Okay. So now in this equation, energy is not known. That is, specific energy is not known to us. Y value is also not known. Discharge is given. That is your 4 meter cube per second. Area, in place of area, you can, as we have considered rectangular channel, it will be b multiplied by y. Okay. So that width of the channel is given. Again, that y value is unknown. Okay. So we have two unknowns. One is y value and one is your specific energy. So what we are going to do, we vary this y value and see how the specific energy vary. Okay. So say first y value we have taken zero point 0.1. Okay. And then we are going to increase the y value by zero point 0.1. Okay. Okay. So suppose what we do, we first substitute the y value zero point 0.1 and find out the specific energy. Okay. Then what we are going to do, we increase the y value and we discharge will be same. Okay. Discharge will remain constant. Okay. Then we change the y value and see what will be your specific energy. Okay. Then again we are changing and see how this specific energy changes. Okay. Then we are going to try to draw a graph between your depth of flow and specific energy. Okay. So if you can draw this using your Excel also. It's very simple. What you are going to get when you draw the graph, say when your depth is zero point 0.1, that is your minimum or the lowest value, point 1, your specific energy is maximum. Okay, you see, when your depth of flow is point 1, that is your lowest value, your specific energy is maximum. Okay, then again you have increased the depth of flow and your specific energy drastically reduced. Okay, then again you have increased the depth of flow, your specific energy reduced. Again you have increased, again your specific energy reduced. Again you have increased, again it got reduced. Then in point 6, again it got reduced. Point 7, again reduced. Point 8, you see in point 8, it started increasing again. It started increasing again. Okay. Point 7, you got 1.116. When your depth is point 7, the specific energy is 1.116. Okay. When your depth of flow is point 8, the specific energy is 1.119. That means it started increasing again. Okay. Then again we change the depth or increase the depth of flow 0.9. You can see this again started 1.1152. Okay. So you use your Excel, okay, to get the value appropriate with the two decimal point, okay, and see how you're varying the width, sorry, depth, how your specific energy changes. What you're going to observe, if you draw the curve, this is your 45 degree at E equal to Y, E is equal to Y. This is your depth of flow and this is your energy. Okay. So this is our 0 point. Okay. So increase of depth of flow is means from here it will go in this direction 0.1, 0.2, 3, 4, 5, and so on. It's increasing, okay, in this order. And from if you start from here, it's 0. Specific energy is also 1, 2, 3, and so on. Okay. Now, when depth of flow is point 1, we will get a maximum value of here. Okay. So what happens once we are increasing the depth of flow, our specific energy reduced, and it reached a point. After that, you are increasing the depth of flow, your specific energy again increases. Okay. So for minimum depth of flow, your maximum specific energy, and once you are increasing your depth of flow, your specific energy is reducing. It comes to a minimum value. Further you are increasing the depth of flow, your specific energy again increases for a particular distance. So this is your specific energy curve. Okay, understood? So for this minimum specific energy corresponding to that particular energy, that depth is called critical depth, YC. Okay, when you increase the depth of flow, your specific energy is reducing and it reaches to a minimum value. And further, if you're increasing the depth of flow, your energy also increases. Okay, that minimum energy, corresponding to that minimum energy, you'll be having, this is your minimum specific energy, E minimum. For this particular minimum specific energy, corresponding to that, we have a depth of flow. That depth of flow is called critical depth. Okay? So if someone asks you what is critical depth is the depth at which the specific energy is minimum. Okay? and the flow occurs at critical depth is called critical flow condition, or you can say critical flow. Understood? So anyone ask you what is your critical depth, you're going to say critical depth is the depth at which the specific energy is minimum, not zero. Okay, it's not zero, it's minimum. The specific energy is minimum for a given discharge, and then flow occurs at that particular depth is called critical flow. Okay, so why it's important? Because for the critical depth we will be having one specific energy, that is E minimum. Okay, apart from this minimum specific energy, you consider any point. Suppose you consider here, suppose specific energy of 4 meter. Okay, so this is your 4 meter specific energy. So if we consider this 4 meter as a specific energy, draw a straight line. Okay, so it cuts the graph into 2 points. I think you have seen that is one point and it is another point. Okay, if you consider a 4 meter of specific energy and you draw a straight line, that means in that particular line your specific energy is 4 meter. Okay, that is your x coordinate, and for y coordinate, that this graph intersect this particular line into two sections. One is 1 and one is 2. Okay, so for 1 we will be having a depth. Okay, we are having one depth, or you can depth of flow, you can say we will be having one depth of flow, and for the section 2 we will be having another depth of flow. That means you can say for both the depth we have same specific energy. Okay, suppose if you say this is your y1 and this is your y2. Okay, so for y1 and y2 we'll be having the same specific energy of 4 meter. Okay, understood? So we have two depth of same specific energy. So in that specific energy curve, apart from your minimum specific energy, you consider any specific energy which is greater than your minimum specific energy, it will gives you two depth of flow. Okay, if you consider here also, it also intersect the curve into 2 points and you will be getting the two depth of flow. Okay, so apart from your E minimum or any value of specific energy greater than minimum value, always having two depth of flow. Okay, so any doubt here? Any doubt, or you people have understood? Then it's fine. Okay, okay, so this two depth is called alternate depth. Okay, so if anyone asks you what is alternate depth are the depths which have same specific energy. Okay, so always remember, one is what is critical depth. Critical depth is the depth at which we have a minimum specific energy for a given discharge. Okay, what is critical flow? The flow occurs at critical depth is called your critical flow. Okay, Then what is alternate depth? Alternate depths are the depths at which we have same specific energy. Okay. Okay. Now okay, this is at 45 degree, E is equal to Y. This is your Y, Y, and this is your E value. E value, okay? Specific energy and depth of flow. Then for a particular discharge, we will be having one curve. Okay. Suppose you consider any cross section. Okay. For that particular cross section, for particular discharge Q, you'll be having one specific energy curve. Okay. Then in the same section, if you change the discharge Q1, you'll be having another specific energy curve. Okay. So this is only one. Okay. Now if you change again to discharge Q2, you'll be getting another specific energy curve. That is your Q2. Okay. So for each discharge, you'll be having one minimum specific energy. Okay. So for this Q1 also, Q1 discharge, you'll be having one specific energy. And for Q2 also, we'll be having one specific energy. Okay. Now, this is our zero. If you join a straight line connecting all the critical point, connecting all the critical or sorry, uh, connecting all your minimum specific energy point, it divide the whole curve into two portions. Okay, one is this portion, one is the upper portion, and one is the lower portion. It divides the curve into two portions. If you consider that first curve, that is Q, or this as Q, that if you join from 0 to that particular minimum specific energy connecting by a straight line, then this line divides the whole specific energy curve into two portions. One is upper portion and one is lower portion. Okay. Then this lower portion is called supercritical. Supercritical. Okay. Or you can say the depth. Okay. This is called supercritical flow. Okay. Lower portion. And upper portion, you can say subcritical flow. Subcritical. The upper portion is called subcritical flow, and lower portion is supercritical flow. Okay, that supercritical flow in that particular area, the depth of flow is always less than your critical depth. Okay, now see if we consider only one graph. Okay, forget about the other two. We consider only one graph. Okay, for that graph Q, for that particular specific energy curve for Q, this line divides the curve into two portions. Okay, one is supercritical and one is subcritical. The depth of flow in supercritical is less than your critical depth, because this is your critical depth corresponding to your minimum specific energy. Okay, so this is your E minimum, This is your minimum specific energy. Corresponding to that energy, we have critical depth of flow. Okay, so all the depth of flow in supercritical is less than your YC. Okay, and here vice versa, that is greater than your YC. Okay, so depth of flow in supercritical flow is less than your critical depth, and depth of flow in subcritical is greater than your critical depth. Okay, so if you consider this is your y1 and this is your y2, so y1 less than yc less than y2. Okay, so y2 is the depth of flow at subcritical, yc is the critical depth of flow, and y1 is the depth of flow at supercritical. Okay, so y1 is less than yc, or yc is also less than y2. Okay. Any doubts? So if you have any doubts, we can discuss, or else we can end our class today here. Okay, no one is having any doubt. Very simple, or what? Anyways, okay, fine then. So if you have not, you don't have any doubts, then we will end our class today here, and the next class we continue from this. Okay, thank you, thank you all.